test ramp is a steel structure 40 feet wide and 100 feet long, built on a runway at the Royal Aircraft Establishment, Bedford, England. The ramp can be adjusted to provide exit angles up to 20 degrees. Tests so far have covered angles of 6 degrees, 9 degrees, 12 degrees, and 15 degrees. At each setting, the ramp has a circular arc profile. Piloting technique is the same as in a normal short takeoff. Accelerate with jets aft. At ramp exit, select nozzles down to about 50 degrees. The Harrier flies a short, part ballistic trajectory, still accelerating, before the pilot starts the transition by moving the nozzles aft again, as in a normal STO. This is the pilot's view through the head-up display. Centrifugal force increases the loads on the landing gear. Over 2.5 G has been experienced traversing the ramp without causing any problems for the pilot. On Royal Navy ships, the pilot uses nose-wheel steering to track the Harrier between the tram lines, which are 7 feet apart. This is much easier than tracking a single center line. On the ramp, launch speed is determined mainly by aircraft weight and by ground roll distance. For a 9-degree ramp angle requiring about 80 knots of speed, 400 feet of ground roll is sufficient. At 12 degrees, a heavyweight launch at only 70 knots needs about 300 feet distance. At 15 degrees, launch speed is 50 knots, needing less than 200 feet, about 4 aircraft lengths. During the trials, many launches have been made stick-fixed. A simple stick positioning device, from which the pilot can easily break out when required, enables trajectories to be flown without pilot input for up to 20 seconds after ramp exit. Some launches were flown without auto-stabilization. Others flown deliberately mistrimmed. In this launch, full forward stick was applied momentarily, just after ramp exit. Launches have been made in bad weather, rain, turbulence, and crosswinds. Up to 18 knots of crosswind was encountered. Few handling problems were met, even with late nozzle rotation after exit. These ski jump trials have proved that very important performance gains are possible with increased safety and reduced pilot workload compared with a runway STO or a flat deck launch. Let's look again at how simple the launch technique is for the pilot. Lined up and ready to go. Trim set and stick positioner in place. The pilot's only task is to steer between the tram lines. Brakes off. Full throttle, accelerate with nozzles aft. Nozzles down. Fly angle of attack in the trajectory. Commence nozzle rotation. Notice how the airspeed is rapidly increasing during the climb away. For clarity, these numbers are repeated on the left. The first night launches were flown with the ramp set at 9 degrees. No problems were found. The line of red lights marks the ramp exit. Pilots find great comfort in this launch technique because of the high initial climb rate, exceeding 1,000 feet per minute. In these trials, over 300 launches have been made from successively steeper ramp angles. 23 pilots have flown from the ramp. All of them agree that the ski jump launch is a remarkable breakthrough in terms of reduced pilot workload, ease of handling, and safety of flight. Summarizing the performance benefits offered by the ski jump, firstly, on land. In a typical heavyweight STO, a 12 to 15 degree ramp can reduce the ground roll distance by 50%. Alternatively, from the same ground roll, the Harrier can carry over 1 ton of extra military load, fuel plus weapons. In typical ship launch conditions at sea, A 12 to 15 degree ramp permits a heavyweight launch with a deck run only about 1/3 of that necessary from a flat deck. Alternatively, from the same deck run, the Harrier can carry well over 1 ton of extra military load. These are the reasons why the Royal Navy is fitting ramps to its Sea Harrier ships. HMS Invincible, the first Royal Navy Command cruiser, already has a ramp at the forward end of her Harrier runway. Whether it's used on a ship or on land, the ski jump promises to become the biggest and most cost-effective contribution to tactical air power since the development of the Harrier itself.